It was such a pleasure to listen to Dan talking about event grid integrations and Alpa on an wonderful case study of real-time use case of data factory logic app and functions. And here I am to share the secret behind building reactive Azure integration application. So I am Erlersi. I am a lead product consultant of Serverless 360 and product built in Azure for Azure. And I'm a part of the organization Covai.co, and I am a certified Microsoft professional and a certified trainer as well. So to get started with an bit of history, like how has been the evolution of application building been? So most of us have been spending more than a decade in building applications. So few years back, it has been like when I need to build in large applications, so I will have to maintain tens of servers, and my end users were fine with waiting for seconds to get the initial response from the application. And hours of offline maintenance is absolutely fine considering the gigabytes of gate data it was dealing with. But imagine or observe the applications that we are dealing with today. So today's applications, the modern applications that we call, are deployed in everything, and they are running on thousands of multi-core processes underneath, which are actually not in my premise, but I take the advantage of cloud hostings to make this possible. I get my application rendered to my end users in multiple forms, like I access them in my mobile phones, it's accessible in my various other machines. There are APIs that makes the interconnections possible across applications. So this is all possible because of advancements in the technologies, and this has made my users also very demanding. My expectation of response times with applications, the model applications that I am dealing with, are not more than milliseconds, and I expect 100% uptime, and the data that the applications are dealing with are in petabytes. So this is how the applications have evolved. Luckily, the technologies with which we build the applications have also evolved over the time to keep up with the expectations of our end users. So today we are going to understand what is a reactive application, which our end users are expecting from application developers like us. So to begin with, let us define the guidelines of a reactive application. When do you say that the application is reactive? When can I accept that the application is reactive? Here comes interesting four parameters that any reactive application is expected to have. First and foremost, I expect my application to be responsive whenever it is possible. So when the application is up and running, I expect it to be responsive. It is expected to give me the response within the best time possible. And of course, this is the cornerstone of usability and utility, right? Even in the modern era, I have multiple alternates. If the application is not responsive, and the user is not even bothered to come back to this application. And in case, so none of the business is fail proof, right? In case a problem is detected, and responsive application is expected to detect the problem quickly and fix it effectively, even before the customer realizes that there was a problem. So this expects and rapid and consistent response times, so that the customer is completely not unaware of the failures or the problems that is going on underneath. So what is the necessity here? So with this consistent and rapid reconciliation is going to give me a high quality of service, and this in turn renders an end user confidence, and the only in this case my end user is going to further more come back to me. That is, this is the behavior, this consistency and detection and fixing of problem seamlessly is what will encourage future interactions of my end user with my application that I have built. So that defines expectation under my application being responsive. So what is resilient? In case of a failure, my application is expected to be responsive. That is, it should not get into a black hole. It should tell the end user that the application is undergoing a problem, and this would be resolved in so and so time. So that is being responsive in face of a failure. But how do I ensure that my application is resilient? I will have to make sure of four important parameters here. Replication. So in case if a part of my application fails, a component of my application fails, I should have a replication of it which can serve my real-time users at this point in time. I cannot rely on a single instance of my application to meet the expectation of a huge scale of my customers. So geo replication comes into picture, wherein if one instance fails, another failover instance should automatically pitch in and then serve my end users. Containment. In case of a failure being arising in one component of my application, the error should be contained within that component. The error should not impact the other components of my application. Say, for example, say I'm doing an e-commerce application and my payment fails. My failure in my payment module should not impact other customers who are processing or viewing the items in the listing. So this is how the containment, a failure in a component should be contained within that component, and it should be isolated from rest of the other components that are part of my business application. This failure in this particular component should be delegated to another component. So making sure that this failure is being resolved by another component in my business application. So you have to design and architecture your application in such a way that the every instance is replicated. It needs to be taken care of at the time of deployment, and in case of a failure, and failure is contained within and scope of the failure, and it is isolated from the rest of the part of your application. This failure is delegated to another component for rectification. In this complete scenario, we also need to make sure that our application is highly available. And most importantly, these failures should not be put as a burden on the client applications that are following or consuming the results of this particular application. So do not burden the client with handling the failures. You cannot expect your client applications, because in the modern scenarios, there are integrations that are inevitable. Like you might have to integrate with multiple other systems. Say, for example, I'm building and monitoring solution wherein I need to send out notifications to the stakeholders. This invites me to integrate with third-party integrations like ServiceNow or an Slack or an PagerDuty. So when these integrations are brought in, I should not expect my monitoring solutions failures to be handled by the underlying notification channels. It's my responsibility to contain the failure and delegate it to another module which can handle it. So that is how I need to build a resilient application. Elastic is a property that I cannot skip, right? Whenever we are daily dealing with varying workload. Say day one, I might have and very less traffic to my e-commerce application. Day two, I announce an wonderful deal, and that brings in an huge traffic to my e-commerce application all of a sudden. Should my application, which is a modern application, scale to this demand seamlessly? Yes. So this elastic application is expected to have an ability to replicate components and distribute load uh, without any experience, that is without any intimation to the customer, like without any feeling that my customer should get that my application should elastically replicate the components to handle the incoming load. And how does this application do? It should have support to predictive and reactive scaling algorithms with live performance measures that will take care of scaling the instances based on the incoming load seamlessly. And this scaling has to happen with cost in mind. It has to happen the cost effective way. So my application should react to the varying workload, having cost in consideration, and the scaling should be seamless. That's my expectation of an elastic application. And when I say it should be message driven, so we are dealing with the components, loosely coupled components, yes, which are decoupled with the help of messaging services like service bus or event grids or event hubs. So that is how my modern application architectures are. So here, why is it very critical? Because I need to support asynchronous message passing. Imagine I have a web interface through which my customer browses for items and then submits an e-commerce order. And I have a backend processing application which is completely decoupled from this front end website, because I need to give an seamless experience of shopping to all the customers. So I cannot put the overhead of processing every order on my front end web application, right? So I completely decouple these two components. My front end website is going to compile an order and push it into a messaging service, and my backend order processing application is going to conveniently pick up the message and process the orders. So that's how I have decoupled the two components of my e-commerce application with the help of a messaging service. So what do I achieve out of here? As an asynchronous message passing, which ensures that my components are loosely coupled. In this scenario, it is also important for me to delegate the failures as messages. So any business will have a number of challenges, right? Say when the order was placed, this item was in stock, but when the order was getting processed, the system found that this particular item is out of stock. So this is a business exception. So this would result in a failure of processing this message at this point in time. So for time being, I need to delegate this failure, park it for further processing, and the system might pick it up after a while. So this should be feasible, or this should be handled by my application, delegating the failures as the messages or non-blocking communication. So here I do not expect my backend application to be up and online every time a new order is placed. That's absolutely not necessary, because I have an complete asynchronous passing, and then the components are decoupled. So the website compiles the message in order into a message, pushes it into the queue, and the backend application can process it at its convenience. And non-blocking communication has to be made sure of. So these are the four key parameters that I expect my reactive application to have to meet the demands of a modern end users. And the business that we are dealing with, or the problem that we are trying to solve, has also gone complex day by day. And this is where we need an technology service provider who can support me in building real-time intelligent applications. So that is where we encounter Azure. So Azure has got an enterprise integration platform and comprehensive set of services that can indeed fit into the real-time business needs. Say, for example, a scenario that we were just discussing about, wherein there was a need to decouple my front-end website and my back-end order processing solution. So here the service bus exactly fits in there. So this service bus can be put between my front end, which is hosted in a web app, and back end, which could be an data transformation service like Logic App or Azure Function, which is capable of defining the workflow of the business requirement. And this service bus queue can handle messages that are coming in as orders, and a Logic App can listen to the queue and pick up and process them. So we saw similar examples being cited by Dan and Alba as well in their sessions, right? So the event-driven architecture that Dan was like helping us with, it clearly fits into real-time scenarios where we need the application to be driven, or be reactive to the purpose the business is dealing with. Yeah, so Service Bus has got a good number of properties that can fit in directly to the business. Say, for example, dead lettering in Service Bus. So we were talking about a business exception of item going out of stock. So that can be efficiently handled with the help of dead letters and Service Bus. I can dead letter a message when I am processing it and push it into an Service Bus dead letter queue. It can be handled even in custom code with consuming the managed libraries that Azure exposes for its services, or by using inbuilt solutions like Logic Apps, which has support to connectors which can perform dead lettering of message into the queue or processing the message in the queue. So this is such one example of to emphasize on how business fit the enterprise integration services offered by Azure R. So now to understand this better, to get a deeper understanding of a real-time business scenario and how to approach solving a real-time business need, let us consider a business use case. Let's get started with understanding what this particular business scenario needs. So here we are going to talk about a fleet management system. Feel free to correlate this with any fleet management systems like an Uber or Volvo, wherein we get a real-time tracking of vehicle informations done, right? So this is also applicable to industries like logistics, wherein they deal with a number of vehicles that are spread across the globe. They are carrying goods from one place to another, wherein it is required for my business to have an clear understanding on where is the vehicle at this point in time, what is its insurance due date, at what speed is the driver moving it, who is the driver riding the vehicle. So these are some informations that would be critical for an fleet management system. So when we bring in the intelligence to this business application, we can solve bigger problems. So this particular business scenario, there is an existing solution which solves a part of the problem, and their intention here is business intention is here, retain this legacy code which is right now existing on their on-prem server. They want to retain this because this is the core business logic that they have spent years together to define. And this is going to be the same way they are going to process the data going forward as well. But collection of data or making the data available to this business logic is going to be made intelligent. That is, they are going to take advantage of technology advancements to build more intelligent system through which they can feed more appropriate information to this core business logic. And based on this, there is an entire workflow or entire set of actions that needs to be triggered. So this is the initial business scenario. Okay, to solve this problem, let us break down the requirements into various business use cases or functional requirements that we are planning to solve using Azure offered services. Yes. So first and foremost, so now they have got telematic devices installed on the vehicles that are spread across the globe, and all these telematic devices are going to stream events. So this events, you can connect this with the series events that Dan was talking about in the beginning. So this is going to be series of events that's going to get streamed from the telematic devices that are installed on vehicles across the globe. So you can imagine the rate of the events. So every 50 minutes, say every 15 minutes, I get a new update from every vehicle. Imagine there are thousands of vehicles that are running, and the system should be capable of ingesting the stream of events to be processed and fed into the business logic for further processing. So I am looking for an event ingester that is capable of ingesting millions of events per second. So I need to also keep in mind that this system that I am defining should be elastic. That is, it should work seamlessly for varying workload. So we need to, at every step, we need to make sure that we are meeting the requirements of a reactive application, because that's what we committed to build. So here I'm looking for an event ingester service that can seamlessly process millions of events that are being streamed by my telematic devices. Yes, and processing or making digesting this stream of events itself is a huge task, right? So that need to be made available to my business application, which is right now in my premise. So I'm looking for a cloud storage service, because I'm going to, except for my existing legacy code, I'm going to have all my new implementations in the cloud, because that is, cloud is going to be my future, and I want to slowly move my workloads to the cloud. So anything that we newly create, we are going to have it in cloud. And this is a strategy many enterprises have taken up. Anything that they newly create, they will create in the cloud. So here I'm looking for a cloud storage service that would allow the on-premise application to process the events. Yes. So the events that are ingested by my event ingester should be saved into my cloud storage. And I should also, so this storage is going to be on the cloud, and my business logic is on the premise. At some point in time, there should be some connection between my on-premise application and the cloud, right? So I need a service that can securely expose the on-prem service to the public cloud. That's my next requirement. I have When this data is being processed, I also need a responsive database with business continuity of enterprise grade security. So this is going to be my ultimate data, and I need to handle it in an responsive database with business continuity and enterprise grade security. So that is my requirement here. Yeah. I need to make this entire application architecture event driven, because I do not expect my on-prem server to keep looking for the application that is availability of the store data that I am looking for. So that is definitely not cost efficient. So we need to design this application also considering cost in mind. Yeah. So I need to make sure that this is not an uh, polling application, right? I should not expect my business application to keep polling for the availability of information. Instead, let me have an event routing service that will let the business application know that the data that you are looking for has come in, and now you can process it. So I need an event routing service to meet the massive scale, and also to make sure that it informs the underlying business application that the data that it is looking for has arrived. So these are my fleet management's requirements. So these are the functional requirements. We also need to take care of the non-functional requirements of reliability, security, scalability, and all. Right? So the best part is all the Azure services come in with these non-functional requirements built in. That is, how do we adhere to that, and how do we take advantage of Azure offered configurations? Let us see as we proceed further. But at this point in time, we can, the one of the key advantages of going ahead with the serverless services is, like, I can get to focus on my core business logic. So, and all other non-functional requirements, or managing, configuring, or operation set of expectations can be fulfilled by simple configurations that I can achieve. That is the beauty of building your applications using Azure Enterprise, like integration platform solutions. And now it's time to map these requirements against the right solutions that Azure offers. So what does the business application do after it processes this information? It needs to pass on this information to an orchestrating service that can perform the follow-up actions with which would also involve third-party integrations. So I need a service which is capable of integrating with third-party applications to execute the follow-up actions. And to decouple this on-prem business logic and my orchestrator service, I need to bring in a messaging service that can decouple the core business logic from the follow-up actions. So these are my functional requirements. So now we are mapping them with the right Azure services. So this is very critical phase of building your reactive application, because you need to choose the right Azure service that can fit in to meet the business need. The best part is, yes, we can put together the Azure services to map, to implement this business application. Let us see which services fit in where. So we had the telematic devices streaming in events based, which gives me the information on the present scenario of my vehicles, all the details about the current scenario of my vehicles. So this event hub ingests the stream of telematic events that are being pushed from my devices installed on my vehicles. This event hub also captures the batches of events into a storage blob. So this process itself is an huge task to perform, considering the scale of data that we are dealing with. Should we check how Azure makes it possible? So let me get into my Azure portal to show you. So these are my resources that belong to this particular application. And I have an event hub. An event hub will have a namespace, and within which I would have an event hub. So this is an container event hub namespace. Within that, I would have an event hub. Yes. So we were talking about the need to capture the events that are being streamed to this event hub. Yes. So this itself is an humongous task, considering the data that we are dealing with. But how easy Azure makes it for me is, I just need to turn on this capture and associate an storage blob location. So I associate a storage account and a storage blob container, and I define the format of my capture files, and this takes care of capturing the incoming events into the designated storage location. It is also possible to have a storage lake configured here as a destination, and here in this scenario I choose to select an storage account. So this overhead of handling the stream of events, making sure of none of the event gets missed out, and efficiently capturing it in an permanent data storage, which my business application can pick up and process. So everything is done to me on click of a button. So that is the advantage of building your application with the help of Azure services. So this part is done. Yes. So next is, I need to emit an event to my event grid, which is my event routing service, that is going to let my on-prem application, which is exposed through and relay, know that the storage data that you're looking for is now available for you to process. So here I need to achieve two operations. One is, I need to expose my on-prem application through and relay to the public cloud securely. So let us see how do I do that. So getting back to the resources in my resource group, I have a relay which does the task of exposing my uh, on-prem service. So I have my relay which is exposing my on-prem service to the public cloud. So that when the moment I expose my on-prem service through a relay, I get an URL that is accessible, through which can be bound to my event grid to pass on the event. So now my event grid need to be bound with my event hub, isn't it? So there are two ways to do it, either by an configuration by ourselves, or We can choose the events offering from that is bound against and resource to define this relationship. See, when I have an event hub, there is an events option which will support emitting events from this service to an selected subscriber. So I can add an event subscription, which is an event grid, and now the event grid is bound to my event hub as an event subscriber. So this, whenever an blob is created, my event grid is going to emit like event hub is going to emit an event to my event grid, and this event grid will pass it on to the relay. So these are mere configurations that is getting my job done for my application. So this way I have my event hub is emitting an event grid, and that is being passed on to a relay, and this relay is connected to my on-prem application that takes care of, and this has a custom code to push the message into my queue. And my logic app can be triggered or by a service bus queue trigger, which makes sure that whenever a message arrives in the queue, the logic app gets triggered to execute the set of operations that is being defined. And or Logic App, as Alpa was mentioning, Logic App supports less code or no code. So wherein I can define my workflow without much of overhead. Say for example, here is an Logic App which takes care of performing and set of operations. Sorry, I got into one queue. Let me pick up an Logic App. Let me filter the resources of type Logic App. So here is one example of an Logic App workflow definition wherein a set of operations are being performed as an whenever a message arrives into the queue. So this has an service bus queue trigger. I associate the queue on which I need this Logic App to be triggered, and I define an frequency. So this is basically an polling. That is, this logic app checks every 1 minute for a new message into the queue. So as we discussed earlier, this can very well be made event driven. I can get to this queue, click on events and associate an event grid and bind it to an logic app, to this logic app. So that makes sure that this queue sends out an event, emits an event to the event grid whenever a new message comes in, and that triggers the logic app. So this decision has to be made based on our business scenario. Say if this is going to be at a predefined timeline, say if my on-prem application is going to give me a message every 1 minute, if it is predefined, then I can very well have an queue triggered logic app which checks for a new message in every 1 minute. So if it is going to be unpredictable, if I do not know when a new order will come in my e-commerce application, in that case it's preferable to have an event driven architecture wherein my event grid is brought in between to let the logic app know when a new order has come in. So this decision we have to make based on the business scenario. So this is how I define my logic app without any a single line of code. I set up an variable, I start an transaction and define a scope. So this is one of the best practices that I'm sure Sandro would be covering in his upcoming session. He is going to share new tips and tricks with Logic App, and defining a scope, having proper names to the connectors, adding proper comments. So these would have a better readability on your Logic App, and it would help the other team members understand the purpose of defining this particular connector and so on. So this is how a Logic App can be defined on a queue trigger with no or less code. And even here, in case of requirement of any customization, you can have your own code written in a function app, and then that can be invoked from here. So let us talk a bit about the service bus queues that we were dealing with. So there are few. like properties of service bus queues that really fit into the real-time business scenario that I would like to highlight here. So let us pick up one of the queues here. Mm, Say a queue has got a good number of properties that would help me uh, um, define the nature of this queue. Say in case of any dead letters, in case of any failures, for example, the logic app that is listening to this queue has gone down for some reason. Yes, so this means that so I have set a message time to live on the queue as 1 hour. I expect that I have an SLA in my business to be met, that any new order that has come in should be processed within an hour. So I say that message time to live is 1 hour. So if this message is not processed for next 1 hour, it is going to get into dead letter, which means there is an business failure or exception that needs to be addressed by an operations engineer or a DevOps engineer, right? So they can set a message time to live, which will push the message automatically into the dead letter end if the message is not processed within this time to live definition. I can also define lock duration, that is, say if the client application is receiving the message, that is peeking this message. There are two modes in which a message can be retrieved. Say if I want to see what these dead letters are. So here is an extension to Service Bus Explorer through which we can peek the messages that are present in my active or dead letter queue. The peak is an safe operation wherein you do not impact any downstream applications that are trying to process this message. So that's usually not the case in case of dead letters. So I can peek into the dead letter messages. I'm retrieving the messages. I can view the message value. I can understand like what was this message content, why did it get into dead letter queue. So it says maximum delivery count exceeded. So to a message property, I can also define the maximum number of times this message can be attempted to be processed. That is, the downstream application would have peaked this message for processing, but it would not have completed it. And the same way, it would have received it more than the specified number of times. Say I said 5 is the maximum delivery count. If the message has been received for maximum number of times and still not completed, then this ends up in this dead letter queue. So these are certain business exceptions that needs to be investigated, and if there is a valid scenario, I need to reprocess them. Let us say in this case it is an employee onboard scenario. So this employee has not been a process onboarded because there was a problem with the downstream application which did not complete the message within the permissible limits. So this need to be reprocessed. So this could be an operational requirement, which is straight away not possible because here, as you see, you can only peek into the message, but cannot reprocess it. But this could be one business need in a real-time operation scenario to submit the message into the queue so that the logic app, which is rectified now or which is up and running now, can pick up the message and then process. So we will also get into the details of these operational challenges as we proceed further. But at this point in time, it is so very convenient or so very easy for me to put the services together to solve my business need. Yes, so this is how I have fit in the right Azure services to meet my business need, and I get to see that my complete enterprise integration has taken a shape, and it is able to meet the business needs at every stage that I identified. So going forward, say you at this point in time, customer decides to the business decides to keep this legacy code on premise and expose it through a relay, but this is not going to be the case forever, right? So they can at any time replace this component with another cloud service, and my design should accommodate that. It should allow extension of the solution or um, re-engineering or revising the solution. So here I bring in an durable function into place to replace my legacy business code that makes sure that my entire application is on cloud now. And this entire application is on Azure now. Yeah. So this brings me to a stage where I have completed the implementation of that. So as I implement my business application, what is that I need to adhere to? I need to adhere to the best practices. So best practices for Logic App itself is an hour session. Similarly, for when we have to cover to about all these services, we need to talk about it forever. But I have a reference and very good reference that I can bring in here. It's a Microsoft's architecture guide reference wherein you can refer to like when you get started with building your business solutions, there are a number of reference architectures that we can refer to understand how do we build our integration consuming the Azure offered integration services. But in this section, I just need to highlight an Azure well architectured framework. What are its objectives and what are the solutions do they provide to help us reach those objectives? So the objectives of an Azure well-architectured framework is reliability. The solution that you build should be reliable. It should be cost optimized. Operational excellence is our ultimate goal. Performance, efficiency, and security. So these terms itself are self-explanatory. So when we say operational excellence, when I do an update to my application, so the this I should be conveniently defining in CI/CD pipeline that without much of effort, the update reflects in my end application. And when I say performance efficiency, invariable of the load that I am dealing with, my application should scale out or scale in to seamlessly to meet the real-time business need. And I need to have secure practices or security controls in place that takes care of ensure that the customer information that I am dealing with is secure. But how does Azure help me attain these objectives? Yes, it does offer services that can help me adhere to that. You have design principles defined. You have Azure well architectured review that is a part of my Azure portal that can review your architecture and then suggest you with changes. Azure advisor, you have the documentation that you can refer to. You have the support channels through which we can reach out. There are partners like us for Microsoft who offer services that would enhance your operational efficiency, and you have reference architectures that we can refer to. So let us have a quick glance about the services and how do we access them here. So here is my resource group. Here is my event hub. Let me get into one of the services. This is available against all the services. However, let us look at it from an one service point of view. I also need to highlight this automation part, like how does Azure support me in dealing with certain automations that would be required. So this particular feature is in preview now. However, I can take advantage of it to it's ultimately an logic app that is getting created underneath, which can send me the cost spent for this particular resource through an automated task. Say I can have monthly report on the cost spent on this resource sent to my preferred notification channel so that I have an eye on how cost efficient am I running it. I can have this entire events coming into this event hub pushed into an service bus topic. So this is not an exhaustive list of what your operation needs are, but however you can define your automated tasks that can improve the overall operational excellence of your service. So you have diagnose and solve problems, which brings in the challenges or any throttling or performance issues or any monitoring alerts that are being brought into our notice here, through which we can understand what is going wrong with our resource and rectify that. However, there are few challenges that every operations or every Azure support faces. So this is very critical for us to define and frictionless Azure support strategy with the help of Azure offered solutions or with the help of solutions from partners of Azure like Serverless 360, with which you can define and you need to define and frictionless support strategy to make sure that you support your reactive application in production. So when it comes to supporting a reactive application, it's not sufficient if we are reactive, we need to be proactive. That is, even before the issue has been encountered, we need to identify them and then fix them. So these are some common challenges that we need to be aware of. To put forth, this is an observation that we have made across the enterprises that I would be glad to share with this community who is building your applications in Azure. And I'm not just going to give you the problem, I can also propose you a solution through which this can be tackled. So here I have a monitoring and observability challenge. Say, if I get into the Azure portal, I showed you I have resources. So I have resource groups. And to solve my business use case, I might have resources that are spread across my resource groups. So for like containing them or to manage them into a logical scope, I have created different resource groups and I might have different teams who are dealing with these resources. Say the queue, which was a part of our application, is exactly not in this resource group. It resides in another resource group. But there would be a need for a DevOps person who is dealing with vehicle management to understand how does the message gets compiled into the queue. So this would be an operational need. And to understand the status of each of my resources, my present solution is I get into the queue, I get into the resource, I understand how the trends of event flow into this resource is, and this is how I'm tackling. And I'm still lacking an holistic view of what is happening with my resources at one place. And that is where we might have to bring in a solution like this, which gives me an holistic view of how my business applications are working and what is going wrong with each one of them. So that is one challenge that Azure integrations are facing, that is monitoring and observability. Though we have extensive monitoring solutions from Azure itself, say Log Analytic, Application Insights, Azure Metrics, we still need them to be brought into the spotlight when something goes wrong. And distributed tracing, what happens with my business when it encounters a failure? Where did it fail? How do I spot that failure? And how do I keep the cost in control? So this any one of us would be facing, like, even before we realize our cost overrun. So it is necessary to have an control on or an eye on how resources are being added to the Azure subscription and how does it grow. Governance and auditing, most importantly, who does what on my Azure subscription is a critical question that need to be answered. So all these might translate into a total cost of ownership on the application. So by how this gets, apart from the resource cost, apart from the infrastructure cost, there is also something associated to called as a support cost. So there are different people involved in the development and operations and support of an enterprise integration application, right? You will have Azure developers, Azure experts, who architects who are part of the organization, who has full control and knowledge on the Azure portal, who deal with your enterprise integrations day in and day out. So what if we involve them in the support, which is the case nowadays, because you have the support team or the business users lack visibility on the solution, or there are security challenges. They do not have much experience on the solution that they are dealing with. So that is where the major part of the support gets accumulated at the with the Azure experts or experienced Azure developers. But in fact, they have to be allowed to innovate for business, not to focus on support. So that is where there is a need for enabling your support team, which can be sorted with the help of tools like Serverless 360, or which is built on the Azure offered monitoring solutions that can help you overcome this challenge. So here is an reactive type of support wherein the business user says, is the follow-up process broken? And this business user says there is no idea. They do not have an idea unless and until they get a support ticket or an call from the customer who says that my action did not get through. So these people do not have visibility on the solution. They do not see anything, and they escalate it to the level 3 IT support team, and they see there is a problem, but they do not know what to do with it because of lack of experience with the solution that they are dealing with. And it finally ends up with the experienced developers who is expected to solve the issue. So this is not efficient. This it's not operational excellence that we want to achieve. This is a reactive type of support which is not appropriate for an reactive application. So here you need a proactive support. That is, you check for the status of your application. Say here is one representation that clearly that maps on to the type of application that we were seeing in the presentation. You clearly see what's wrong. You understand that dead letters, you fix that, and you keep your business growing. And you have an report on how the resources are added, and you have in control on the pricing of your Azure integration right from here. So here, this is a solution built in Azure using Azure APIs for Azure operational excellence. So we need to be aware of providing the right required support to the reactive application to make sure that we meet the expectations of our end users. So this brings us to the summary of this session wherein we talked about what is a definition of a reactive application as per a reactive manifesto. We built to meet the business needs, and we chose the right Azure services that fit exactly into the business need to solve the Azure, enterprise integration need. And we got a recommendation to adhere to the best practices and how do we define a frictionless support strategy. So this brings us to the end of the session. And here are some useful links that I would like to expose you to. So this blog covers in detail about how do we choose the services and how do we build an enterprise integration. And this is a blog of mine. And here is a reference to Microsoft reference architectures. And Serverless Notes is a platform. It's a community platform that we have built wherein you can find tips from experts in Azure space sharing how do we build in Azure. Thanks for listening to me, and if you have any questions, I'm happy to address them.
Thank you, SLRC. So are there any questions? We have 8 minutes for any questions. So SLRC, I really like what you shared there, the manifesto, because often that's missing, especially in Azure integrations. We apply the general principles. However, I think with the manifesto, it does take it a bit further, especially from an end user perspective as well, and from a service delivery perspective, right? We're not just talking technology principles now. We're not just talking error logging and resiliency. We're taking it one step further. So that's what you've actually addressed, which is really interesting. In fact, yesterday it was actually none other than Kent Weir from Microsoft who actually shared the Automation Center of Excellence.
Yeah.
And so I think what you've done today is you've done something similar, but you've done that for Azure integration services.
Yes,
So
that's.
I would like to open up the discussion to on this really actually what you've actually just mentioned on the center. Here we go. So Amit's got a question here. So Amit's asking, how do we compare relaying on-premise to on-prem data gateway?
Yeah, so relay is to expose your on-prem service, that is our service, securely to your public cloud. And on-prem data gateway does something similar. Yeah, It acts as a bridge, is what I could understand. I have really not used on-prem data gateway, but Relay helps you expose your on-prem services securely to your public cloud. Yeah.
I mean, I think what you're asking is the on-prem gateway. Is that correct? The on-prem gateway. Um,
He correctly mentions about on-prem data gateway, which connects mostly the on-prem data services to the public cloud.
yeah, awesome.
Yes,
Thomas is
specific.
asking, I guess you can also use API management to expose your on-prem services.
Yeah, not only on-prem services, even your cloud services. Say if you have a Logic app, Azure functions, you can expose them through API management to have an additional layer of security. Yes.
Ah, yeah, it means asking, yes, data
Mm.
gateway. Yeah.
A secure firewall hole on your on-prem data. That's correct.
Okay, any other questions? We've got 5 more minutes.
Yes.
In the meantime, are you able
Yes.
to share your contact details on blog in the chat, please?
Absolutely. Yes, I can do
Great
that.
stuff.
Yes. Yeah.
Okay, great feedback from Diaz saying
Thanks,
nice
Diaz.
session.
Thank you. Thanks, Samit. Thanks for having me today here, Ras.
Thank you very much. So I think that's it. That brings us to the end of this session now, guys. So thank you once again, Ezra, from joining us all the way from India,
Yes.
sharing that great feedback. I think you covered lots of great principles there. And you also saw some of the gaps as well, which is really important, right? It's very
Yes.
important to be aware of those gaps and limitations. So thanks once again, and yes, hopefully we will see you again soon. So that was Ezra Rossi joining us all the way from India,
Thank you,
and
Ras.
we will start our next session in 4 minutes' time.